to 8.5, setting up a chi-square test for homogeneity or independence. So we've talked about chi-square test for goodness of fit. So now we're going to talk about homogeneity and independence. So the nice thing is even though these are two different tests, the method is exactly the same. Okay, so you're going to use the same method. It's just, what's the null hypothesis look like? What are we trying to do when we use this test? So we're going to be looking today at sort of differentiating between homogeneity and independence, looking at the null and alternate hypotheses, and then also looking at the conditions and choosing the appropriate method, or same method, but the appropriate test, okay? In order to do that, I need to bring to you guys how you need to start differentiating in your mind between all these different statistical tests that we have learned, right? So we have spent the majority of second semester on these 4 tests: 1 proportion z-test, 2 proportion z-test, 1 mean t-test, and 2 mean t-test. Remember, proportions are z-tests and means are t-tests, yeah? And then we started this unit talking about the chi-square goodness of fit test. And so now we're kind of focused here on homogeneity and independence, okay? And we're going to back it up. There's also a linear regression t-test we haven't talked about, but you've actually seen that mini tab output. It's like when we were looking at line of best fit and making the lines, and then we had the little where it gave you mean, didn't give you mean, it gave you slope and y-intercept. I don't know if you remember that, but there's a test for that too. So we're here, chi-square, goodness of fit, which we already talked about. Okay, we knew we were going to use goodness of fit because we always had 1 sample and 1 variable. And we might be looking at a distribution, but 1 sample, 1 variable. Okay, so for example, my 1 sample would have been like a package of M&Ms. My 1 variable would have been color. And then I was looking and comparing, did my package of M&Ms and M&Ms distribution match each other? Okay, so that was my 1 sample, 1 variable. So look at this nice flow chart here, okay? Independence will be similar, but you might be looking at more than 1 variable. So 1 sample, but more than 1 variable, okay? For example, are orange M&Ms more chipped than red or brown, right? So we take a sample of M&Ms and we're comparing color distributions and chipped or not chipped. So now we've got 2 variables, which this is probably something they thought about. Does the coloring of the candy coated shell, is the coloring affecting the integrity of the M&M? Right. And so we could talk about independence. See, I could be eating M&Ms again right now. I'm really regretting my choice on this lesson now, if I'm being honest. Anyways, another thing that I could be looking at though is if I were given more than 1 sample, and then I would be doing a test of homogeneity, right? So if I had an off brand of M&Ms and then actual M&Ms, and I wanted to compare if their color distributions were the same. So I would take my sample of off-brand M&Ms, which I can't even think of off-brand M&Ms right now off the top of my head, and I want to know, is their proportion of reds equal to real M&Ms proportions of reds? Proportions of orange equal to real proportions of orange, right? So I would use this test, homogeneity, to compare those proportions given 2 samples, okay? Homogeneity, 2 or more samples. Independence, 1 sample, more than 1 variable. And this does get a little bit confusing, okay? Just because sometimes it gets like, which one's a variable? Which one's a sample? Like I'm confused. So we're gonna try to clear it up. The appropriate hypotheses for chi-square for homogeneity, okay? There is no difference, this is a null hypothesis. There is no difference in the distributions of a categorical variable across populations or treatments. So let's back it up. Homogeneity was more than 2 or more samples, right? So let's say we're talking about the M&Ms versus the off-brand M&Ms versus M&Ms. So there's no difference in the distribution. So this is two samples, right? Two different things, two populations, off-brand population, real M&M population. Are the distributions the same? So there's no difference between the distributions, or is there a difference? So that is your appropriate hypotheses for homogeneity. Difference or no difference in the distributions. For independence, let's back it up. Independence has one sample but multiple variables. One sample but multiple variables. So like M&Ms is chipping and color related, or chipping and color related, right? So does red chip more, does orange chip more, are chipping and color related. So back to this, there is no association between two categorical variables, meaning it doesn't matter what color the M&M is, I'm going to get about the same amount of chipping on all the colors, right? It's got an equal distribution of chipping among the colors, or an equal amount of colors among the chipping, however you want to think about that. And then the alternate hypothesis is that they are associated. So that means the blues chip more, or the reds chip more, or orange never chips. So orange got it going on. So it's a lot like Stacy's mom. Anyway, so that's your difference between homogeneity, which means there's no difference in a distribution, and two categorical variables where you're saying there's no association between the two variables. Okay, hope that makes sense. All right. When comparing distributions to determine whether proportions in each category for categorical data collected from different populations are the same, the appropriate test is homogeneity. So think about that. To determine whether proportions in each category for categorical data collected from a different population are the same. So proportions for fake M&Ms equal to proportions of real M&Ms. To determine whether row and column variables, my computer here is trying to update. So I'm going to pause you while I get my slides back. Okay, so to determine whether row and column variables in a two-way table of categorical variable might be associated, like chipping and color, this is called independence. Yeah. Essential knowledge for our independence, normal, all of that. So for independence, you have to have simple random sample. So for a test of independence, like chipping, this is multiple variables, okay? You have to have a simple random sample. For homogeneity, you could also have a stratified random sample, and that's fine. In fact, probably preferred, because you're going to want to have all your different strata, like colors, kind of sampled out. I'm not being ridiculous tonight. Okay, and then you've got same 10% condition when sampling without replacement. And then all your expected counts should be greater than 5. So the only real difference here in our conditions from goodness of fit test is your homogeneity has that added stratified random sample added to it. Okay. All right, gummy bears. Everyone knows that Haribo gummy bears are the best. Seriously, they're so good. I might have a thing for candy. But what we wondered is if the distribution of color was the same for off-brand. This should sound. So we took a random sample of Haribo gummy bears and a random sample of Meyer, some gummy bears, and compared the distribution of colors. What kind of test is it? Think about it. So did we have a mini tab output? Nah. Is there a table of frequencies? Well, now you have to think about the data you would collect. I would collect gummy bear colors for 2 brands. So would I have a table of frequencies? Yeah, I would. All right, so I'm going to use a chi-square test. How many samples am I pulling? 2 samples. I'm pulling one from Haribo and one from however you say this, Mayhair, Mayjair, however you say it, right? Two samples. Two samples means homogeneity, okay? So we have two samples, one categorical variable, which is color. All right. Is there an association between taco tongue, which is, and evil eyebrow, which is, I can't do this one. But my one eyebrow kind of does it naturally. So anyway, let me start again because I've now rambled. Is there an association between taco tongue and evil eyebrow? The data for a random sample of 600 students is collected. Do we have convincing evidence that the ability to do the taco tongue and evil eyebrow are associated with each other? Okay, so obviously I didn't give you the data. We're going to look at it in the next video though. So here we go. Don't have this. Go to this. Do I have a table of frequencies? So think about the data you would collect here. You'd be collecting 600 and you would need to collect yes or no on taco tongue and yes or no on evil eyebrow. Now think about how you would do this. You would have to say a taco tongue yes and a taco tongue no. And then your next would be, I could do the taco tongue and I can also do the eyebrow. Or I couldn't do the taco tongue, but I can do the eyebrow, right? So you would have to collect the data in a way that ended up with a table of frequencies. So yes. How many samples? 600 senior students. That would be one sample. So now I'm either going to go goodness of fit or independence. Do I have one variable or do I have two? Well, taco tongue is one, evil eyebrow is two. So this looks like independence to me. One population, senior students, two categorical variables, taco tongue, evil eyebrow. Okay, pizza. Can you tell I got nighttime here? It's always weird when it does that during my videos. A random sample of 200 students was asked to come sample. No. A random sample of 200 students was asked to sample a new type of pizza that the school was considering using as a replacement for the current pizza. Each student stated if they were a freshman, sophomore, junior, or senior, and also if they liked the new pizza more than the current pizza or not. The school would like to know, is there a relationship between grade level and pizza option? Is there a relationship? So pause the video, see if you can get an answer. Welcome back. I hope you said independence. So in this case, how many people did we sample? Well, we sampled students. See, it didn't say we took a sample of freshmen, took a sample of sophomores, took a sample of juniors, took a sample of seniors, right? It said sampled students. Then from there, it said we asked the students two questions: grade level, pizza type. And we want to know, are they related? Anytime we're checking for association between two things, that's independence. Are they related? So the question here is, if I pick a junior, do I know whether or not you're going to like this new pizza more or not, just based on the fact that you're a junior, right? Or not? Because if I take this data and the proportion of people who say yes is equal among sophomores, juniors, and seniors, then there's no association between grade level and pizza. But if very few sophomores say they like it, most juniors say they do, and most seniors say they don't, then there's an association between grade level and whether you like the pizza or not, right? And we actually did a check for independence way back in our probability unit where we said, like, given the grade level of the person, can we tell the probability of something occurring? It was that given, right? Is the probability the same whether or not that other piece was given? That's kind of what you're thinking about here, okay? All right. Another high school is also considering changing their pizza vendor. This school selects a random sample of 50 freshmen, 50 sophomores, 50 juniors, 50 seniors. Each student tries the new pizza and states whether they like it more than the current pizza or not. The school would like to know if the distribution of opinion differs across grade levels. Pause the video. All right, welcome back. I hope you said homogeneity. So this is very similar. In fact, you're pulling the same information with, you're stratifying your sample, right? But it just said a random sample of 50 freshmen, 50 sophomores. So now you've got a sample of sophomores, as freshmen, and juniors, and seniors, and so on and so forth, okay? So now your samples are more than 2, and it automatically takes you to homogeneity. And notice the difference in the language here. It doesn't say, is there an association? It says, check the distribution across the grade levels. So you're saying, is it the same or not? So very, very similar. But the name of the test is different because the way the question is worded changed. So just be careful. A pizza shop claims that 30% of orders are placed on Friday, 20% on Saturday, 10% are placed on the other days of the week. A global pandemic may have changed this distribution. The manager investigates so he knows how to staff the pizza shop appropriately. I mean, we don't want to have a ton of people there on Wednesday when we don't need them all. He selects a random sample of 300 orders and classifies each one according to the day of the week the order was placed. He wants to know if the distribution of orders is the same as it was before the global pandemic. So we're still in a chi-square test, right? Because we're still going to have a table of frequencies. How frequent did it occur on Monday, Tuesday, Wednesday, Thursday, Friday? Chi-square. How many samples? We got this one random sample of 300. How many variables? 1. Right? Day of the week. That's our variable. Wow. So that means we're chi-square goodness of fit. I tricked you on this one, didn't I? I tricked you. Nah, I win. So those are your 3 types of tests. You're going to be looking at an assignment to go with this. So good luck. Know that you're going to get this wrong at first, and then it'll feel more comfortable as you go through them. Okay? I hope this helps. Have a wonderful day, and I will see you on the next video.